Okay, ladies and gentlemen, this one I want you guys to do. And just a couple hints. Amplitude of the voltage given by 120, omega's 377, phase angle of the voltage 60. Figure out the impedance of these two things in series. And then take that equivalent impedance and figure out the equivalent impedance of the parallel combination of this and this. So you would have this would be impedance of this is j omega c. So impedance of the parallel combination will be given by, and I should say reciprocal of the impedance of the parallel combination, will be given by the reciprocal of the impedance of the capacitor plus the reciprocal of the equivalent impedance of the resistor and inductor. And then, of course, the current is going to equal to V over CP. Notice something. Multiply V by the reciprocal. Once you have the reciprocal, you're done. Okay, those are the hints I'm going to give you. You guys do it on your own. I'm going to pause the video and try it on your own, and then when you come back, I'll go through the the rest of the solution. So pause now. Coming back from the pause, did you get the answer? Let's figure out what that answer is. So a couple things. The omega 377 voltage is written in phasor notation. Watch out for the signs. That's the point they were trying to make on the there we go. This blue stuff here, the blue circles, that's the point they were trying to make, is you've got to convert from the sine to the cosine to get the proper phase angle. Okay. The impedance of these two components and the impedance of the capacitor, figure out the equivalent impedance of the entire network. You got the numbers, voltage or current equals V over the equivalent impedance of this network. Divide these two numbers to get this. Subtract 9 from negative 30. And you got that? So that's the end of it. Did you get this answer? Hope you did. Okay, this is for your practice and for your understanding. So do these things. Next, admittance. Admittance is the reciprocal of impedance, kind of like conductance is the reciprocal of resistance. If it's purely resistive, there's no capacitors or inductors, then this does equal 1 over the resistance. If you have capacitors and inductors, though, it's not that simple. And then susceptance is the imaginary part of the admittance. Admittance and impedance. Admittance is the reciprocal of impedance. Impedance is the reciprocal of admittance. In DC circuits, conductance is the reciprocal of resistance. Resistance is the reciprocal of conductance. New terminology. That's all it really is here. And sometimes using one or the other can help problem go a little smoother, better, cheaper, faster. And formulas. So we multiply top and bottom by this, because when you multiply r minus jx times r plus jx, you get a real number. And then you have this on the top. So then we can identify conductance and susceptance, what they are in the formulas. Formulas of all the equivalences. So how voltage and current react with the three components: a resistor, inductor, and capacitor. Impedance of the components, and admittance, reciprocal impedance. Like I said, pure resistance. The conductance is a reciprocal of resistance, as we can see from this formula. That's only if you don't have capacitors and inductors. Admittance and admittance for the inductor here, admittance for the capacitor here. This would probably be a good table to have with you on examinations. Parallel combination of impedances. If we're dealing with impedance, the reciprocal of the equivalent parallel impedance is equal to the sum of the reciprocals of the individual impedances. Okay? So we have this. This is the impedance of the capacitor. It is not the capacitance. 10 ohms is the resistance. So in this case, we simply add the two together. Admittance of the resistor, admittance of the capacitor, add them together. We get it. Series combination, if we're dealing with impedance. Series impedance is just the sum of the individual impedances. Okay. And again, you can get the impedance easy, just the sum of these two. Admittance is the reciprocal of the sum. And so, get my pen back here. There we go. Reciprocal impedance, reciprocal admittance is the sum of the two impedances, you'll notice. And then we get take the reciprocal of that, crunch a little math, and we get the final result here. Okay. Let's take a look at this problem here. So we have voltage, and I'm gonna, I just noticed the time on this video. I'm gonna do this problem when we come back. So next video, I'll start this problem.